Welcome to the Deep Dive. Today we're tackling something really fascinating. That journey from just being competent at something to achieving, true mastery. What does that actually feel like? And how does your brain make that kind of quantum leap? To really get at this, let's use this great analogy from our sources. Picture two woodworkers, okay? In this sun-drenched workshop, first you've got Clara. She's really skilled, what we're calling C1 competence. Give her blueprints. She executes them perfectly, knows her wood, measures precisely, follows the rules. Her work, it's technically excellent, totally reliable. But then there's Kenji. He's the master, C2. He's working differently. He feels the wood, see its potential, finds a flaw. He doesn't panic, he improvises, makes it a feature. His work just feels alive. So what does that leap from Clara's C1 to Kenji's C2? Is like the difference between someone who speaks French fluently and a native poet, right? Or a good engineer versus a legendary one. Feels kind of magical.
It really does feel that way sometimes. But what's amazing, and what our sources really dig into, is that this isn't magic. It's actually physical. It's a measurable, profound restructuring happening inside your brain. So our mission here today is to explore the neuroscience behind this shift. And maybe more importantly, give you some actionable strategies, things you can actually do to start this journey. We're talking about upgrading your brain's biological hardware, reorganizing its software, and tapping into these hidden networks.
Upgrading your brain's hardware. I like that. Okay, so before we can leap to C2 mastery, we need to really understand C1 competence. Because getting to C1, that's already a massive achievement, right? Thousands of hours of work.
Oh, absolutely. It's built on dedication. And neuroscientifically, the star player in the C1 brain is the prefrontal cortex, the PFC. It's right behind your forehead. Think of it as the brain's CEO. It handles your working memory, holding info while you juggle it. It does the planning, the decision-making, and it enforces rule-based behavior, consciously applying what you've learned. So when someone at the C1 level tackles a hard task, their PFC is, as the sources say, lit up like a Christmas tree on an fMRI. Really working hard.
You can almost feel that effort, can't you? So the PFC is doing the heavy lifting, but it sounds like it's also using a lot of energy. A gas guzzler.
That's a perfect way to put it. It's incredibly energy intensive. That's exactly why you feel so mentally drained after intense focus. Effective, yes, but very costly for the brain.
Makes sense. So what's actually building this C1 capability? What's the underlying mechanism?
It really comes down to neuroplasticity, the brain's ability to change, and specifically strengthening synaptic connections. The old saying holds true: neurons that fire together, wire together. Think about forging a path in a forest the first time. It's hard work, requires conscious attention, but each time you walk it, the path gets clearer, wider, easier. The C1 brain has essentially built this huge, well-organized library of knowledge and skills. And the PFC, it's the diligent librarian, carefully finding and applying the right information.
Okay, so C1 is capable, organized, but it sounds like there are limits.
Definitely. It can be a bit slow sometimes, rigid too. And under pressure, or when facing something totally new where the rules don't apply, it can stumble. If the complexity swamps the working memory, the C1 brain struggles. So to get to C2, we need to move beyond this conscious, sometimes brute force method.
Right, and this is where it gets really mind-bending. The C1 to C2 jump isn't just adding more books to the library, like you said. The sources describe it as changing the very architecture of the library itself. Installing a high-speed fiber optic network and training a new kind of librarian, one that works on intuition. That really sounds like a quantum leap.
It is. It's a fundamental shift. And it involves, according to our sources, 3 key neurobiological transformations: myelination, functional reorganization, and network integration.
Okay, let's break those down. Myelination first, the broadband upgrade.
Exactly. Myelination is where this fatty substance called myelin wraps around the axons, the long cable-like parts of neurons. Think of it like the plastic insulation on an electrical wire. And its effect is just stunning. It drastically speeds up nerve impulses. We're talking by a factor of up to 100 times faster.
Whoa, 100 times.
Yeah. It allows the signal to jump between gaps in the myelin sheath. It's called saltatory conduction. Makes communication incredibly fast and efficient.
So that must be the basis for things like muscle memory, or when thinking just feels automatic.
Precisely. That's cognitive automaticity in action. The C2 brain, in its area of expertise, is heavily myelinated. Those key circuits are super fast. But how does it happen? It's triggered by deliberate, consistent, and importantly, challenging practice. Pushing yourself, making errors, correcting them that signals specialized brain cells, oligodendrocytes, to wrap those active axons in more myelin.
Ah, so it's a biological process. That's why it takes years, not just weeks. You're literally building faster pathways.
Exactly. It's slow biological work.
And the result?
Yeah.
Those key circuits become so fast, so reliable, they just don't need the PFC micromanaging them anymore. The Grandmaster feels the game because those pattern circuits are lightning fast.
Precisely. And that perfectly leads to the second big change, offloading the CEO. As skills get myelinated and automated, the brain does something brilliant. It delegates. It shifts the workload away from that energy-guzzling PFC to older, more efficient structures, especially the basal ganglia deep in the brain. The basal ganglia are the masters of sequence, habit, procedural memory, the how-to knowledge, like riding a bike or typing. As you move towards C2, huge chunks of complex skills get handed over to them.
Okay, I can see that difference. The C1 engineer debugging code. Okay, first check logs, then the API, then replicate. PFC driven. But the C2 engineer just knows where the bug likely is. Their basal ganglia runs the whole diagnostic sequence automatically.
You've got it. That chunked procedure runs almost subconsciously.
Yeah.
And the incredible benefit. The C2 Master's PFC is now free. It's liberated to focus on the bigger picture, on strategy, creativity, improvisation. Just like Kenji, the woodworker, isn't thinking about how to hold the chisel, he's thinking about the art.
Amazing. Okay, what's the third transformation? Right. Symphony of networks.
Right. So modern neuroscience sees the brain less as isolated spots and more as interacting large-scale networks. There are three crucial ones for this C1 to C2 shift. First, the executive control network, ECN. That's your focus network, very dominant in C1 when you're concentrating hard. Second, the default mode network, DMN. This is often called the mind-wandering or imagination network. It's active when you're resting, daydreaming, and it's critical for insight and creativity. And third, the salience network, SN. Think of it as the switchboard. It monitors everything, decides what's important enough for your attention, and crucially, it helps toggle between the focused ECN and the wandering DMN.
Okay, so how do these networks behave differently in C1 versus C2? C1 sounds like it's either hard focus, ECN, or mind-wandering, DMN, maybe quite separate.
That's a good way to think about it. C1 might be more rigid switching, but C2 exhibits what researchers call dynamic network flexibility. This means a C2 master can be deeply focused, ECN fully engaged, but at the same time, their DMN is humming along in the background, making loose, novel connections. That's where those aha moments often come from. And their salience network. It's become expertly tuned. It can pick up on subtle, relevant cues in the environment or from internal thoughts that a C1 brain might just ignore as noise.
So they can hold the details and the big picture simultaneously, juggling focus and intuition. That feels like a real hallmark of mastery. Wow, this is all incredibly insightful. Understanding the what and why is fascinating. But okay, let's shift gears. How do we actually do this? Let's get into the actionable toolkit, the strategies.
Right, because understanding is one thing, applying it is everything. These aren't just theories, they're evidence-based ways to actively drive this C1 to C2 transition.
Strategy 1, deliberate practice 2.0. You mentioned that triggers myelination, but it's different from just regular practice.
Hugely different. Standard practice might get you to C1, maybe maintain it, but deliberate practice, based on Anders Ericsson's work, is specifically designed to push you towards C2. It's not about just doing reps. It's about systematically identifying your specific weaknesses, the things you find difficult, and targeting those with intense focus right at the edge of your current ability.
That edge, that's where the struggle happens, right? And that struggle signals the brain.
Exactly. Struggling just outside your comfort zone, making mistakes and immediately correcting them, that's the biological signal. Hey, this circuit is important but faulty. Insulate it. Myelinate it now. Easy practice doesn't send that signal.
Okay, so how do we structure this? What's the how-to?
First, you deconstruct the skill. Break it down into the smallest possible parts. Second, isolate and amplify. Pick one specific weak component and focus on just that, relentlessly. Third, you absolutely need immediate feedback. You have to know instantly whether you succeeded or failed. That could be a coach, watching video playback, using specific software. And fourth, rinse and repeat. Master that one weakness, find the next one, and attack it. It's often not fun, it's grueling.
I'm thinking of that example from the sources, Okiko, the violinist. Already C1, great player. But she spends hours on just 3 bars where her intonation is slightly off, playing them slowly, backward, different rhythms.
Exactly, until that specific neural circuit is perfectly myelinated. That's the targeted effort needed.
Okay. Strategy 2, The power of unfocus. This feels counterintuitive. We need less focus sometimes.
It's a paradox, isn't it? But yes, profound insights often bubble up during periods of rest, not intense concentration. Think of focus as loading the information into your brain, and unfocus is the time your brain needs to integrate that information, to connect the dots in novel ways.
So that's the default mode network, the DMN getting its turn.
Precisely. When your conscious mind rests, the DMN gets busy. It consolidates memories, links new ideas to existing knowledge, runs background simulations. That's where those shower thoughts or sudden insights during a walk come from. So strategic rest isn't being lazy. It's an active, crucial part of the deep learning process required for C2.
Okay, how do we intentionally cultivate this? How do we unfocus effectively?
One method is pulsed learning. Intense work bursts, maybe 90 minutes, followed by genuine rest for 20, 30 minutes. And genuine rest means not just switching to email or another demanding task. Instead, engage in low cognitive load activities. Go for a walk, listen to instrumental music, do some light gardening, maybe just stare out the window, let the mind wander. And critically, prioritize sleep. Sleep is the ultimate DMN consolidation tool. It strengthens important connections, prunes away irrelevant ones. For anyone serious about mastery, 7 to 9 hours of quality sleep needs to be non-negotiable.
I love that example of Rohan, the software architect. Stuck on a problem, told to stop thinking about it. Then on a walk, boom, the banyan tree root analogy pops into his head from the DMN.
It highlights how the DMN works when you give it space.
Okay, strategy 3. Desirable difficulty. Making learning harder. That sounds weird.
It does initially, but the principle is solid. Your brain learns things more deeply and retains them longer when it has to work harder to retrieve or understand the information. Easy come, easy go, essentially.
So how do we introduce this desirable difficulty?
2 key methods our sources mention are interleaving and varied practice. Interleaving means mixing up different types of problems or sub-skills within a single practice session. So instead of practicing all of skill A, then all of B, then all of C, that's called blocking, you'd mix it up. A, B, C, A, C, B, etc.
And varied practice.
That's practicing the same core skill, but under different conditions each time.
Why does this work better than just blocking out practice? Blocking feels more efficient initially.
It feels faster, yes. Blocking gives quick gains in performance during the practice session. But long-term retention and the ability to apply the skill flexibly, much weaker. Interleaving forces your brain to constantly figure out which strategy or knowledge to apply. It has to load and reload different mental models. This feels harder, but it builds much more robust and flexible neural pathways. It teaches the underlying principles, not just rote procedures. And it really hones your ability to discriminate, which is key for C2.
Right. So the student mixing math problems from different chapters, not just doing chapter 5. Or the basketball player shooting from different spots, different types of shots, like in a real game.
Exactly. Not just 100 free throws from the exact same spot.
That example of Lena, the medical student, interleaving cardiology, neurology, endocrinology cases, it made diagnosing complex patients much easier later on, even though the study sessions felt harder.
That's the power of desirable difficulty. It builds adaptable expertise.
All right, strategy 4, metacognition. Thinking about thinking. How does this help us get to C2?
Metacognition is like becoming the coach of your own brain. It's about stepping back and observing your own thought processes, your learning strategies, your assumptions, your biases, objectively. Why is it vital? Because mastery requires brutally honest self-assessment. Where are my real weaknesses? What assumptions am I making? Where are the gaps in my understanding? Without that awareness, you can't effectively direct your deliberate practice. You're flying blind.
Makes sense. You need to know what to deliberately practice. How do we actually do metacognition?
One great technique is the Feynman technique. Try to explain a concept you're learning in the simplest possible terms, like you're teaching it to a child. Anywhere you stumble, use jargon, or get confused, bingo. That's a gap in your understanding. Another powerful tool is decision journaling. When you make an important decision, write down why you made it, what factors you considered, and what you expect the outcome to be. Later, revisit it. Compare the actual outcome to your expectation. It helps you see your biases, like maybe overconfidence or wishful thinking. And of course, seek external feedback. But don't just ask, how did I do? Ask mentors or peers to critique your thinking process. What was I missing here? What assumptions did I make?
That's CEO Thibault using a decision journal, realizing he fell for confirmation bias with his product launch. That self-awareness allowed him to change the whole company process. That's a C2 leadership move, born from metacognition.
Exactly. It turns mistakes into learning opportunities.
Okay, strategy 5. Boundary expansion, thinking outside your specific field.
Yes, the C2 brain isn't isolated. Tree masters are often brilliant at analogical thinking. They see a connection between a problem in their field and a concept from a completely different domain, leading to breakthroughs.
Why does that work? Why not just dig deeper in your own specialty?
Digging deeper is important, obviously, but major innovations often come from connecting previously unconnected ideas or spots. Exposing your brain to different fields, science, art, history, whatever, gives your default mode network more diverse raw material to play with. It builds cognitive flexibility. You start seeing underlying patterns that cross disciplinary boundaries.
So how do we actually expand our boundaries?
Read widely, voraciously outside your core area. If you're a programmer, read history. If you're a doctor, read philosophy or poetry. Develop a serious hobby in a totally different domain, maybe painting, learning an instrument, architecture, and actively look for analogies. Constantly ask yourself, what is this problem fundamentally like? What does this remind me of from somewhere else?
Like Pierre, the chef, who took an organic chemistry course, suddenly his kitchen is a lab, and he's thinking about polymer degradation, leading to new cooking techniques. That's a fantastic example of connecting different worlds.
It really is. It shows how cross-pollination can spark C2-level innovation.
Okay, one last strategy, number 6. The physical foundation. This sounds basic, but maybe it's most overlooked.
It often is, tragically. But the sources emphasize this fundamental truth. Your brain is a biological organ. It runs on biology. All these sophisticated strategies we've discussed, they won't work optimally if the underlying hardware of your physical brain is compromised.
So sleep, nutrition, exercise, they're not just wellness things. They directly impact our ability to reach mastery.
Absolutely critical. Sleep isn't downtime. It's essential for consolidating memories, strengthening those neural pathways you built during practice, and literally cleaning the brain of metabolic waste via the glymphatic system, which is most active during deep sleep. Exercise boosts blood flow, oxygen, and nutrients to the brain. It also increases BDNF, brain-derived neurotrophic factor, which is like miracle grow for neurons, promoting growth and connection. And nutrition. Well, the brain uses a massive amount of energy, about 20% of your body's total, despite being only 2% of the weight. It needs high-quality fuel. Omega-3 fatty acids for cell membranes, antioxidants to protect against damage. Remember, myelin is literally made of fat and protein. You need the building blocks.
So the how here isn't a quick technique, it's a lifestyle commitment, isn't it?
It really is. Prioritizing 7 to 9 hours of quality sleep, getting regular cardiovascular exercise, eating a balanced diet rich in whole foods, fruits, vegetables, healthy fats, lean proteins. This is the bedrock. You can't build a C2 skyscraper on a shaky foundation.
That makes so much sense. You know, weaving through all these strategies, it feels like there's also a mindset component. These neurobiological changes, they don't happen in a vacuum, right? They need a certain psychological approach.
That's a crucial point. They absolutely require a particular psychological stance, as you put it. It's not just what you do, it's how you approach the entire process. One of the biggest factors is having a growth mindset, Carol Dweck's concept, believing that your abilities, your intelligence, your creativity, they aren't fixed. They can be developed through dedication and hard work.
So the C1 person with a fixed mindset might say, oh, I'm just not good at strategy.
Right. Whereas someone aiming for C2 with a growth mindset thinks, okay, my strategic thinking circuits need strengthening. How can I deliberately practice that? This mindset is essential to embrace the inherent discomfort of deliberate practice. If you think failure means you're not cut out for it, you'll quit when it gets hard.
What else? What other mindset aspects are key?
A high tolerance for ambiguity and complexity. The C1 brain often likes clear rules, black and white answers. The C2 master becomes comfortable operating in the gray areas. They can hold conflicting ideas in their mind, see nuance, appreciate complexity. That's a sign of sophisticated thinking.
And I guess patience.
Oh, immense patience. Myelination is slow. Rewiring brain networks takes time. The C1 to C2 journey is absolutely a marathon, not a sprint. The modern world bombards us with quick hacks and instant gratification, but that's the enemy of true mastery. The C2 master understands this. They're playing the long game. They trust the process.
What an incredible map you've laid out for us, from Clara, the skilled C1 artisan, to Kenji, the intuitive C2 master, and seeing it not as magic, but as this tangible, physical process. Upgrading the hardware with myelination through deliberate practice, reorganizing the software by offloading to the basal ganglia, and learning to conduct that symphony of brain networks, the ECN, DMN, SN for flexible focus and insight. It's quite a transformation.
It really is. And while it definitely requires effort, strategy, and patience, the encouraging thing is that it's also, in a way, democratic. The tools we've talked about: deliberate practice, strategic rest, desirable difficulty, metacognition, boundary expansion. The physical foundations, these are available to everyone.
That's a really empowering way to think about it.
Yeah.
You're not just stuck with the brain you have. You're not merely a user of your brain. You could become its architect, its sculptor. You're actively laying down myelin, forging connections, tuning networks with every focused effort, every thoughtful rest period. You are literally building mastery from the neurons up.
And perhaps the final thought to leave everyone with, building on our sources, is this. The path from C1 competence to C2 mastery is perhaps the ultimate demonstration of neuroplasticity in action. It's really a testament to this profound and quite beautiful fact that with the right knowledge, the right strategies, and consistent effort, we can actually change our own minds. We can become masters of our own making.
Masters of our own making. A powerful idea to reflect on. Thank you so much for taking us through this deep dive today, and thank you, our listeners, for joining us. We hope you'll think about how these insights might apply to your own journey toward mastery, whatever field that might be in.